Assalamu alaikum. In this video I hope to discuss 2024 A-level paper. Let's look at the first question. Which of the following physical quantity has a unit but no dimension? Planck constant, surface tension among them. Sound intensity level has unit but does no dimension. Look, beta is equal 10 log I over I naught. Then log values are just numbers. Then this is also a number. Therefore beta doesn't have any dimension because it is a number, but they have the units of decibels. Hence it has a unit but no dimension. Then the answer is fifth. Second question. Here we want to find the least count of this vernier caliper. So we know the equation for least count. Least count is 1 main division over number of vernier division. Here don't misunderstand, it is mentioned 1 centimeter has 20 subdivision, which means the main scale is 1 centimeter divided by 20, otherwise 10 over 20 millimeters, which is 0.5 millimeter. Then the main scale is 0.5 millimeter and the vernier division is 20. So we have 2.5 divided by 100, which is 0.025 millimeters. Third question. The kinetic energy of a projectile at its maximum height is 1/4 of its initial kinetic energy. So when we take a projectile motion, we know that at the maximum we only have its horizontal velocity, and at initial we will have their components. Before we find the components, let's try to find the relation between v and v dash. They have mentioned the kinetic energy at maximum is 1/4 that at initial. So let's try the equation for kinetic energy. Kinetic energy is half mv squared. So kinetic energy is half mv squared. At maximum and initial, m will not change, half will not change. Therefore kinetic energy is proportional to the speed. So they mentioned that if the initial kinetic energy is E, the kinetic energy at maximum is E by 4, 1/4. So I can try to get a relation between V and V dash. So at maximum kinetic energy is E by 4. Initial it is 4. That means kinetic energy is 4 times. So if kinetic energy is 4 times, velocity is 2 times. That means V dash is 2V. This angle is theta. Then we know that in a projectile motion, the horizontal velocity does not change. The horizontal velocity remains the same. Then V dash cos theta must be equal to V. So V dash is 2V as we found now. Then cos theta is half, which means theta is 60 degrees, and the answer is fifth. Consider the following statements made about pair of action and reaction forces. They are equal in magnitude but opposite in direction, which is correct. They act only on objects touching each other. This is wrong. One example is just think about a magnet, South Pole and North Pole. Then we have another magnet, South Pole and North Pole. They will attract each other with equal force. This is one example. Then gravitational force is another example. Forces between charges is another example. So there are many instances. they act on the same object. That is also wrong. Then the answer is only A first. Question number 5. A bullet hits a wooden block on a smooth horizontal surface and embeds with the block. So here the law of conservation of linear momentum is valid for collision. Yes, because for any collision, conservation of linear momentum is valid. Conservation of energy is valid for collision. Of course, yes. Because if you take a collision, we can classify collision into elastic, perfectly elastic, partially elastic, and finally perfectly inelastic. So if you take perfectly elastic, conservation of linear momentum is conserved in all of them. Conservation of energy, yes, in all of them the energy is conserved. Conservation of kinetic energy, if it is perfectly elastic, it is conserved. If it is partially elastic, thus loss. If it is perfectly inelastic, then we have the maximum loss. So here, how to identify perfectly inelastic? If an object, let's say we have two objects colliding with one another, after collision, if they combine into a single object, then it is perfectly inelastic. Something like this, where this object embeds into this block. Therefore, this is a perfectly inelastic collision, then kinetic energy will be loss. Hence, this statement is correct. Then the answer would be 5th. Which of the following statement is true about muon? So in particle physics, you get 1 or 2 MCQs. In matter and radiation, so usually you get MCQs from this particle physics. It is better to remember the table. So if we take the particle physics, the table, we have quarks and leptons. So if we take the quarks, we have up quark, down quark, charm, strange, top, bottom. Next we have leptons. So if we take the leptons, we have electron neutrino, mu neutrino, and ton neutrino. And then we have the electrons, muons, and tons. I will explain a little in detail because most of you might not have proper idea about them because you study them at the very end of your syllabus. So if we take this table, in this table, these are the elementary particles, the small particles that these neutrons, protons, all of them are made up of. Okay, so these quarks and leptons together, quark plus lepton together, we call them as fermions. Okay, just try to remember these names. So fermions means they make up the matter. That means now atoms are made up of some matter, right? So these are the particles that it is made up of. And then what are these quarks and leptons? Quarks, they participate in strong bond. Leptons, they do not participate in strong bond. So what is this strong bond? just think about the nucleus. Inside the nucleus you have these neutrons, protons, right? So those neutrons, protons, they are made up of quarks because they have strong forces inside them holding them together. Then you have the electron. Electron is not in the nucleus, right? It is outside the nucleus. So they are not participating in the strong bond. That is why we call them as leptons. Okay, so then if you take this table, in this table these have these have plus 2 by 3 charge, and this one has minus 1/3 charge, this one has 0 charge, this one has minus 1 charge. So in this table, as we go down, the charge reduces. Okay, so charge reduce, and these are known as first generation, second generation, third generation particles. Then when the generation increase along this direction, mass increases. Okay, along this direction mass increases. So these second generation, third generation, they are unstable and they want to come to the first generation, so they decay to become first generation. So this is the overall idea you need to remember about these particles. So now let's come into this question. They say muon is a lepton. Yes, it is made up of 3 quarks. No, leptons are not made up of quarks. Its mass is larger than that of electron. Yes, because they are second generation. It is true. Question number 7. We need to draw the ST graph, or we need to find the ST graph for this VT graph. So initially we have a acceleration in the ST graph. This is how we show acceleration, then uniform velocity, deceleration. Here we have the graph in the negative side. I used to project it to the positive side, then draw its ST and project it back. Okay, so this is what I need. So this is the shape we get, but we can select 3 or 5. So how to select between them? Now if you look at the 5th graph, the displacement is 0. The displacement is 0, which means the particle has gone forward and then returned back to its original place. For this to happen in a VT graph, this area should become equal to this area, but when you look at the graph, you understand those two areas are not equal. Therefore the answer should be third. 8th one, you need to find the magnitude of torque applied. So omega is equal omega naught plus alpha t. Omega is 20, omega naught is 40, time is 10 seconds. Then we get 10 alpha is minus 20, alpha is minus 2. So tau is equal to I alpha. I is given as 8, alpha is minus 2, therefore torque is minus 16 Newton meters. Hence is a correct answer. Astronomical telescope, they have given the focal length of the objective and the angular magnification, and they say this is in normally distant. Then we know that m is equal f over fe. So fo is given as 80, magnification is 20, then we get the fe should be 4 centimeters. When astronomical telescope is in normal adjustment, we know that the separation between the lenses is equal to f4 plus fe. So length is equal f4 plus fe, then that's 80 plus 4, 84 centimeters in length. Hence the third answer. Question number 10. A sound emitting source emits frequency 1000 Hz and it is moving directly towards the stationary observer at a velocity of 0.9. So this is the speed of the source. V is the speed of sound. So we have an observer who is at rest, not moving. Then we have a sound source which is generating sound at a frequency of 1000 Hz and is moving with velocity 0.9 v. The velocity of sound in air is v. We know the equation for apparent frequency, that is velocity of sound with respect to observer over velocity of sound with respect to source into f real. So the observer is already at rest. Therefore the velocity of sound with respect to observer is going to be v. Velocity of sound with respect to source. The source is moving. I need to stop the source. So 0.9 v in this direction. When I stop the source, I also need to stop, I'm going to find relative, right? Therefore, I'm going to apply 0.9 here as well. Then velocity of sound with respect to source is this resultant, which is going to be 0.1 v, and the real frequency is 1000. So I get 1000 divided by 0.1, which is 10,000 Hertz, and that would be the fifth answer. The Faraday's law of electromagnetic induction is related to what? So it's related to law of conservation of energy, because here what happens is magnetic energy is being converted into electrical energy. So here energy conversion happens and it's based on the law of conservation of energy. Question number 12. Now we have a circular part that is removed from a circular plate. So for these types of question, what we can do is, first we can think this way. We have a large circle and from that we have removed a portion. Okay, we have removed a portion. Now this question is to find the center of gravity of the remaining part. But what I'm going to do is, I'm going to say I am going to put back the remaining part and the removed part together. That will give me a total circle whose center of gravity is going to be at the center. Okay, the center of gravity of the combination will be at the center. Then I'll say this part is having a mass of mc and the center of gravity to this part is r, and here this part, let's say it is mr remaining. Okay, and let's say this is m dash when we combine. So this part, let's say the distance is at r bar. So first of all, when you're dealing with these types of question, you have to find the masses. So mass is equal area into area density sigma, because this is having a uniform density. There's a uniform circular plate, right? So mass is proportional to the area, because this is constant. Mass is proportional to the area, but this is a circle, therefore mass is proportional to pi r square. Pi is a constant, then mass is proportional to r square. So if you look at the smaller circle, the one we removed, MC, it is having a radius r, so it is proportional to r square. Next, if you check the remaining part, it is not a circle, right? Therefore it's hard to get it that way. Let's get it in another way. But look at the combination. When you put back when you so when we put the remaining part and the removed part and the remaining part together, it forms a complete circle m bar, which is proportional to 4r squared. Why 4r squared? Because the large circle has radius 2r. So we have to square it. Now we can get the mass of the remaining. Remaining is proportional to the difference of them, right? 3r square. Now using principle of moment, I can say the principle of moment says sigma of, or the finding the center of gravity is sigma of mx is equal sigma m into x bar, which means you can take moment for each component separately, add them, then it will be equal to the resultant's weight into distance to the center of gravity from the point we take moment. So I am going to take moment about the center G, then clockwise will be positive, anti-clockwise will be negative. So here we have mr into r bar positive minus mc into r, that is equal. Now what is the total mass? M bar. What is the distance? 0. Then we get mr, that is 3r square into r bar equal mc, r square into r. So r squared cancel, r bar is equal to r by 3. So the answer would be at a distance of r by 3, right? So if this distance is r by 3 is something like this, which means the answer would be D. Okay, so you can use this method for similar any type of question. You might get squares or similar question, then you can approach this question in this method. Two sound sources A and B are placed at a distance r from a point, and they are, the measured intensity level is 72 decibel and 92 decibel. So let's say from a point we have two sources A and B. When we measure for A, we got 72 decibel. For B, we got 92 decibel. And the intensity for this is given as I, and we need to find I dash at the same point. I can use the difference equation. Delta beta is equal 10 log I new over I old. Then delta beta. Now let me take B as new. Let me take so we had delta beta is equal 10 log I new over I old. Then I said let's take IA as old and IB as new. So this one had 72 dB, this one has 90 dB. Then the change between them is plus 20 equal 10 log I new is B, right? Therefore I B over I. So when I simplify, I get IB over I is equal 100. That means IB is 100 times I. Fifth answer. Question number 14. We have an ideal transformer which has 200 turns in the primary coil and 400 turns in the secondary coil. So this is a step up transformer. We know that number of secondary coil or number of primary coil is voltage in S over voltage in P. So secondary is 400 over 200, which is 2 times. Then Vs is not given. Vp is 110. Then Vs is 220. We know that 220. Then if we take a transformer, in a transformer, power is the one that is getting transmitted from one to the other. So the power in the first is Vp into Ip, which is equal Vs into Is. If it is ideal, then Vp was 110 and Ip is 10. Vs we found as 220 into Is. So Is is 5 amps. So it would be the fourth answer. The coefficient of static friction between a small coil and the surface of the table is 0.36. Then we have 30 rpm. What is the maximum distance from the center of the turnable at which center of the turntable at which the coin will not slide? So for this when we place a coin and try to rotate it above the center, friction is the one responsible for the centripetal force. Then I can write Fr is equal mr omega squared. That is also equal to mu r, but r is mg. Then we get r is equal mu g over omega squared. Now omega should be written in or given in radians per second, but we have rpm. So 30 rpm. R means revolution per minute. So 30, a revolution is 2 pi radian divided by 60 minutes means minute means 60 seconds. But they mention consider pi as 3, right? So if you simplify, you get 30 over 6 over 60, then 10, so that is 3. So in radians we get 3. Then r is equal 0.36 into 10 divided by 3 squared, 9. So which is 0.4 into 10, which is 4. 0.04 into 10, which is 0.4 meters. Then in centimeters it is 40 centimeters. Question number 16. We have two boxes, 5 kilogram and 10 kilogram, which is placed on a rough horizontal surface. Then we will have friction. They have given the kinetic friction coefficient, and they say 100 Newton is applied to box A. Then the reaction between the both boxes is 40. So here we get 40 and here we have 40. We need to find what is the coefficient of kinetic friction between this surface. So here we will have friction, right? FB, and here we have FA. So if I write this equation for the system, I get 100 minus no, I'll write the equation for A. If I write the equation for A, on A we have 100 newtons, then 40 newton, and friction, which is mu r. Mu is 0.5, r is 100, that means 50. So we get 100 minus 90 is equal to ma. So A is 1. Now let's consider box B. If I consider box B, the forces acting on box B is 40 Newton and the friction FB. So 40 minus FB is equal to MA. M is 5, A is 1. Then we get FB is 35, which is equal mu into R. R is 50. Then mu is 7 by 10, which is equal 0.7. So the answer is first. Question number 17. A steel metal ruler is to be used in a measurement so that the millimeter readings are accurate up to 5 into 10 to the minus 5 millimeter at a certain temperature. What is the maximum temperature variation allowable during the measurement? Okay, now try to understand this question really well. Now if we take a meter ruler, the gap between these two division should be 1 millimeter. Okay, now this is a steel ruler. Okay, now I am going to use this to measure something. I am going to measure this object. So because this is a steel ruler, just think, when you hold the ruler, you are transferring heat. You are transferring heat to the ruler. Using that heat, it will expand, right? So they ask if this is the allowable expansion for a millimeter, what is the allowable temperature change? So the rulers, 1 millimeter is allowed to increase by a certain amount, and still we would consider it as a valid reading. So how much it can increase per millimeter? 5 into 10 to the minus 5 millimeters. Okay, this is the allowable expansion for a millimeter. So delta L is equal L alpha delta theta. So delta L is 5 into 10 to the minus 5. L is 1 millimeter. Alpha is 1 into 10 to the minus 5 delta theta. So delta theta is 5 degrees Celsius. So it's allowed to change by around 5 degrees Celsius maximum. So the answer is fifth. We have 5 resistors and a battery are connected as shown in the figure. The EMF of 6 voltage, battery has EMF of 6 voltage, and it also has negligible resistance. We want to find what is the resistance over here. For this question, first let's use the potential divider method. So let me tell you a simple way to calculate when you have resistors in parallel and they are in a ratio. Look, 1:2 ratio. So the combination would be, now we have 6 volts, so this is 50 ohm, then here we have 50 ohm, so here we have 30 ohm. So how to find the combination of these two? You can use the proper method, or the fastest method would be, when you have a ratio, write the larger number on top. And what is the ratio? 1:2. So get the sum, 1 plus 2, so that is 3, then this is 20. Okay, so this would work only if the ratio is 1:2 form, 1:2 something, then it is easy to get this way. So from there, sum of these two is 50 and 50 is in parallel, then half, so we get 25. So this is 50, this is 25. Now to find the voltage, we can divide it proportionally. We know that V is equal to IR, but I is constant, therefore V is proportional to R. So here you look, it is at the ratio 2:1. 2:1. That means 1/3 the supply voltage appears here, which is 2 volt. 1/3 of 6, 1/3 of 6 is 2 volt. So here we have 2 volts. And if you look at the ratio here, it is at the ratio 2:3. That means across this you will have, if you write as a fraction, 2/5 of 2 volts. That means 0.8, and that is the voltage across R4 as well. Therefore the answer is 0.8. Here they ask what is the wavelength at the top. Okay, what is the wavelength at the top? Now we know that this is a transverse pulse. The equation for transverse pulse is V is equal root T over M. So here they have mentioned it's a uniform rope. That means M is going to be, simple M is going to be the same. Okay, V is equal root T over M, then simple M is same, then we get V is proportional to root T. But what is velocity? That is F lambda. Then F doesn't change when propagating, so lambda is proportional to root T. So at the bottom we have a tension that is equal to weight of this, that's 20. Then lambda 1 is proportional to root of 20, and at the topmost it is going to bear the entire weight, so 4.5 kilogram, which is 45 newtons. So lambda 2 is proportional to 45. Then lambda 1 over lambda 2 is equal 20 over 40. Sorry, 20 over 45. I can divide this by 5, which is 4 over 9 square root. Then lambda 1 over lambda 2 is 2 by 3. Lambda 1 is given as 2. Then lambda 2 is 3 lambda 1 divided by 2. So it's 3 centimeters. Fourth answer. Question number 20. We need to find which of the statement is true. So in all of them they are talking about the extension. So let's try to get the equation for extension. F over A is Y E over L. So E is equal F L over AY. So here they mention equal length subject to the same tension. F and L constant. Then E is proportional to 1 over AY. So if extension should be large, product of these two should be low. So the product is 2, here the product is 4, here the product is 1, here the product is 2. So the answer would be C. C has the largest extension. A thin circular loop of radius 2 cm is kept just below the surface of a liquid. If a force of 0.04 Newton is required to pull this loop out of the surface of the liquid, what is the surface tension of the liquid? So we have a loop in a liquid and we are going to pull it out. To pull it out, we need to apply 0.04 newtons. Now here, let me get a cross section of this part. Let me choose another color, say cross section of this part, and show how the forces are going to act. Now this is that loop. So this is the liquid. The liquid is holding onto this loop from the outside as well as the inside. So outside T, inside also you have a tension that is pulling down. Then we are applying a force in the upward direction to take it up. So the upward force is 0.04 and the downward force is 2 pi r T into 2. Why 2? Because we have a force from the outside as well as from the inside. Then 0.04 is equal pi r, radius is given, right? Radius is 2 centimeters. 2 centimeter means 2 into 0.01 into T. So if you divide these two, you get 4 and 4 cancel, then T is 1 over 2 pi Newton meter minus 1. So that would be the fourth answer. A uniformly charged hollow metallic spherical shell, what is the variation of V with R from the center? Now we know that when we have a metallic sphere which is charged, then there's no electric field in the inside, then the potential doesn't change from what is on the surface. So on the surface and inside we have the same potential. With distance it decreases. So the answer would be second. Question number 23. A soap bubble of radius r was made at the end of very narrow tube as shown in the figure. More air is blown into the tube isothermally to increase the radius of the bubble to 2r. The pressure inside the bubble was increased. We know that P is equal, delta P is equal 40 over R for a bubble. So if R increase, delta P reduces. Therefore this is wrong. Surface energy of the bubble was increased by 4 times. So we know that surface energy is area into T, right? So area for a sphere is 4 pi r square. So if you look, surface tension is same, pi 4 is same, then energy depends on the radius. So radius has been doubled. From here to here we have doubled the radius. So if the radius is 2 times, energy becomes 4 times. So this is correct. C, volume of the bubble was increased by 4 times. So what is the volume? 4 by 3 pi r cube. 4, 3, pi is constant, volume is proportional to r cube, radius doubled, then volume is 2 to the power 3, which is 8 times. So this is wrong. Then only B is true. So here a current I flows through a uniform metal wire which is maintained at constant temperature. Which of the following graphs show the variation of power dissipation in the wire in a current? We know that P is equal to I squared R. So we get Y is equal to mx squared graph. That is third. Two thin glass lens in contact has a combined power of 3 diopters. If one lens is convex and has focal length 20 centimeters, what is the type and focal length of the other? So we have two lenses. We know one of the lens is convex. We don't know what is the other lens. But the combined power is 3 diopters. So first let's try to find out what is the power of this lens. This lens is having a power 1 over f. F should be substituted in meters. This should be in meters. Then we get 20 centimeter means 20 over 100 meters, which is 100 over 20 and 5 diopters. Convex lens has positive power. Okay, why positive power? Because power is how much powerful is the lens in converging the light. So we know that convex lens converges, therefore positive power, but concave lens diverges the light, therefore it is having a negative power. So this lens has plus 5, then this lens should have minus 2. So minus, that means it should be a concave lens. It should be a concave lens. And let's see, 2 is equal 1 over f. F is equal 1 over 2 meters, which means 0.5 meters. So that is 50 centimeters. Then the answer is second. A potentiometer wire AB shown in the figure has length 100 centimeter and resistance 10 ohm. So AB has resistance 10 ohm. And it is connected in series with a resistance R and cell EMF 2 volts. The balance length for a small source EMF 10 millivolt is found to be 40 centimeters. So for 10 millivolt we get 40 centimeters. So for 40 centimeters is proportional to 10 millivolt, then 100 is proportional to how many millivolts? Here we have to multiply by 2.5 times, right? So this would be 25 millivolt. Okay, this would be 25 millivolt. So from A to B the EMF is 25 millivolt. So how much is the current? V is equal to IR. 25 millivolt is equal I into 10, because current will not go through this when it is in balance. The entire current will go through AB only. Then I is equal 2.5 milliamp. Now let's try to find what is the voltage across this. So if you take this loop, here we have 25 millivolt, here we have 2000 millivolt. Then how much is across this? 2000 minus 25, so that is 1975 millivolts. So V is equal to IR, I is 2.5 into R. So R is equal, when we divide we get 790 ohms. So we get the first answer. During decay of radioactive uranium to, cannot remember the name, 235 92 turns into 231 91. So here you can see there's a reduction in the atomic number. That means there should be an alpha particle that was released. So sorry, the mass, when we consider the mass, total mass is now balanced, but when we consider the atomic number, it is not yet balanced. That means another beta particle should have been released. So one alpha particle and one electron. One alpha particle and one electron. First answer. Once again, you might not have, sometimes you might not have an idea about these particle or the matter radiation part. So let me quickly explain what happens here. What is an alpha particle and what is this beta? Alpha particle is actually the nucleus. Nucleus means the helium nucleus. Sorry, alpha particle is the helium nucleus. Helium nucleus. So if you take a helium has 2 neutrons and 2 protons in its nucleus and 2 electrons. Okay. So alpha particle is only the nucleus. That means it has lost both of its electrons. So alpha particle is helium 2 plus. So that is why alpha particle atomic number as 2, atomic number, and the mass as 4. Okay, I'm not sure, I forgot whether we call it as the atomic number. Anyways, that number is 2, and here we have 4, which is the mass, and this one has charge plus 2. Okay, then what is this beta particle? Beta particle, this is actually an electron. Think electron has almost 0 mass and has a charge, so that's an electron particle. So to understand what's happening over here, when it comes to radioactive particles, these radioactive particles tend to radiate for a few reasons. So one is their mass is high, their atomic mass is high. That is one reason. Otherwise, one is atomic mass is high. Second one is neutron to proton ratio is higher than 1. Okay, neutron to proton ratio is higher than 1. If atomic mass is high, then they tend to reduce the mass, that is by releasing an alpha particle. Okay, so say we have an atom that is having atomic number Z and mass A. Then this one's atomic mass is high, this A is really high, then it becomes unstable, and it wants to become stable by releasing an alpha particle. So what is an alpha particle? Alpha particle, as I mentioned earlier, is the helium nucleus. So its atomic mass will reduce by, atomic number will reduce by 2, because it is going to release a proton and a neutron, and its atomic mass will reduce by 4, because it is going to reduce its mass by 4 because it's releasing 2 protons and 2 neutrons. Okay, so it will release an alpha particle. So we call this as alpha decay. This is especially when the mass is high, atomic mass is high, and it wants to get stable by reducing its mass. The second method is N over P is greater than 1. So here, when N over P is greater than 1, the atom tries to convert a neutron into proton. Okay, it tries to convert a neutron into proton. So how does it convert a neutron into proton? If you take a neutron has mass 1 but no charge. But now it will turn into a proton. Proton also has mass 1 but it has charge. So during this, it will release an electron, a fast moving electron. Electron has charge 1 and mass 0, and then for conservation of momentum, it will release a neutrino, electron neutrino. So this we call as beta decay. So say we have a particle whose atomic number is Z and mass is A. So this is going to do a beta decay. During this, you see a proton is getting added, right? A neutron converted into proton. Then the atomic number will increase. But what about the mass? Mass remains the same. There's no change in mass, and this will create a fast moving electron. We call it as fast moving electron, beta particle, and electron neutrino. That is to conserve the linear momentum and energy. So we call this as beta decay. So beta decay happens when N over P ratio is more than 1. Alpha decay happens when we have higher atomic mass. At a time, only one of them will happen. But here, look, we have an alpha particle and a beta particle, right? So both alpha decay and beta decay has happened. But actually, this uranium would have turned into an intermediate atom, and that is also unstable, which underwent a beta decay and produced this Dysprosium or something. Okay, so if you get statement wise question, you might get questions related to this. So have an overall idea, what is alpha decay, what is beta decay, and can both of them happen together. So those types of ideas. Okay, if you have a doubt about how this neutron turns into a proton, while ago we discussed about quarks, right? This particle physics. So neutron is made up of up, down, down quarks. Up is plus 2/3, minus 1/3, minus 1/3. Then they add up to 0. And proton is up, up, down. Then plus 2 by 3, plus 2 by 3, minus 1. So if you do the math, you will get plus 1. So here you can understand, if one of the down quark turn into up quark, we will get proton. So what do we have in a down quark? We have minus 1. So here minus 1/3. So you can understand, from this minus 1/3, if an electron is released, that means the charge is releasing a minus 1. If it releases a minus 1, this becomes minus 1/3 minus minus 1, which is plus 2/3. So that is what turns into an up quark. And if you look at the equation, it's the exact same thing that is happening over here. As a result, we get a proton and a fast moving electron and a neutrino to balance the linear momentum and energy. Okay, absolute humidity of air inside a room of volume room's volume is 75 meter cube, and the AH is given as 0.04 kilogram per meter cube. RH is 75. Then how much? So RH is 75. Then how much should we add vapor? How much vapor should we add? So let's say the saturated AH is X. Let's say saturated AH is X. Then from that 75%, that is 1/4, is equal 0.04. Then the saturation is 0.16 kilogram per meter cube. Okay, now we have 0.16 into 75 meter cube. Then we get, if we multiply 75 into 0.16, that is sorry, this is 3/4, right? This should be 3/4. So divided by 3. So we need to multiply 0.16 into 25, that is 4 kilograms. Sorry, X is the maximum, absolute humidity is 0.04, RH is 75. How much additional water we need? Okay. So if we find the saturation would be 4 into 0.04 divided by 3 kilogram per meter cube. So that is 0.16 by 3 kilogram per meter cube. Now this is the total amount. So if I get the difference between them, now currently we have this much per meter cube. To fill we need this much per meter cube. If I get the difference, I will get how much is required for each meter cube. So let's say m dash or h dash 0.16 by 3 minus 0.04, that is equal 0.04 by 3 kilogram per meter cube. Then mass required is equal 0.04 by 3 into 75. So you have to multiply by 25, which is 1 kilogram. We have 3 point charges that are brought to vertices of an equilateral triangle. Out of them, 2 charges have plus q. Total work done to bring the charges to the vertices is 0. What should be the value of the third charge? Okay, now we have 3 charges on the vertices of an equilateral triangle. Both of them have charge plus q. One of the charge is unknown, q dash. Now earlier I have told that the energy stored between charges actually stored in the bonds. Then you can easily write the equation like 1 over 4 pi epsilon naught q1 q2 over r square. That is how you write the equation for energy stored between 2 charges. But here you have multiple charges, right? Let's start from q dash. If you look at q dash and q, there's a bond, energy is stored here. So if I write the equation for that, I will get q into q dash, q into q dash over r square. Next we have q dash and this q. Between them we have a bond. If I write the equation for that, once again I get the same. Therefore I'll write like this: q over q dash over r square, because that 1 over 4 pi epsilon naught thing is same. Now I have considered this bond, I have considered this bond. Only this bond is to be considered, that is between this and this. So plus q over r square, it should be equal to 0. So q dash plus q dash is 2q dash plus q squared is equal to 0. Then we get 2q dash is equal to q dash minus q by 2. Now say you want to write an equation for a square. How to write it? Now let's say in a square we have 4 charges, q1 q2 q3 q4, and distance is x. Then here you have a bond. You will write 1 over 4 pi epsilon naught q1 q2 over x. So we consider this. can you see from here to here also we have a bond? Okay, I mean there are interactions, therefore there will be charge stored between them, energy stored between them. Then if I consider this, that is q1 q3 over root 2x plus q1 and q4 has a bond, so that will be q1 q4 over x. So we have considered all the bonds related to q1. Let's go to q2. If we go to q2, bond with q1 is already checked, bond with q4 needs to be checked, then that will be q2 q4 over root 2x, so that is done. Then q2 q3 over x, this is done. So all the bond of q1 q2 is now okay. Let's go to q3. In q3, this is already checked, this is already checked, we have to check this. So plus q3 q4 over x, so this is checked. Then look, for q3 this is checked, this is checked, this is checked. For q4 this is checked, this is checked, and this is also checked. Then this will be the energy stored in a square. So like this you can easily write the equation for any system. A small solid sphere made of material having density beta is released from a depth h below the surface of the water in a tank. What is the maximum height this sphere will rise from water? So we have upthrust, we have mg. If density of water is greater than beta, then upthrust is greater than mg, so it will accelerate in the upward direction. Then u minus mg is equal to ma, but u is v rho g minus, instead of m I can write v beta g equal, instead of v beta a. So volume is getting cancelled. We have acceleration is equal rho minus beta g divided by beta. So acceleration is now this particle is accelerating, then I want to find what is the velocity here. Okay, so v squared is equal to u squared plus 2as. V squared is equal, now initially it starts from rest, therefore 0, 2 into a is rho minus beta over beta g into h. From here it goes under gravity, so here find once again v dash becomes 0. So v dash squared is equal v squared plus 2as. Final velocity is 0, but the initial velocity is 2 rho minus beta over beta gh minus 2g, let's say h dash, then 2 and g is getting cancelled, h dash is rho over beta minus 1 h. So we get the fifth answer. So here this is related to cooling. We know that in cooling R is equal Ka theta minus theta R. So what is this rate? This is the rate of heat loss. We know that when a body is losing heat, we can write as Q over T. But what is Q? mc delta theta divided by T is equal Ka theta minus theta r. So here let's read the question and find what are the constants and remove them. We have two solid sphere A and B made of same material with identical surface properties. So K is same. The diameter of this sphere is A is half that of B. That means area will change. Mass also will change. Okay. Are made of the same material. Then C is same. They are heated to the same temperature. So excess temperature is same. Then allowed to cool to the same environmental condition. The initial rate of cooling of A and B are RA and RP respectively. The initial rate of cooling. So rate of cooling is d theta over dt. Okay. Hot or cool, how do you measure? By temperature. So we need to find out on what does delta theta over T depend on. So here, if I remove the constant, it depends on the area over the mass. But this is a sphere, therefore area is 4 pi r square. Then I can say area is proportional to 4 pi r square, but 4 pi is once again constant. Then area is proportional to r square. Otherwise d square. Both of them are same, no problem. What about the mass? Mass is v rho g, right? Mass is v rho g. Sorry, v rho. Rho is constant, same material. Volume is 4 by 3 pi r cube. 4 by 3 is constant, pi is constant. M is proportional to r cube. Otherwise mass is proportional to d cube. So first and second I'll use that here. So delta theta over T is proportional. Area is r square, sorry, d square, and this is d cube. Then we get rate of cooling is proportional to 1 over d. So that is the relation in final. So they say radius of, the rate of cooling in RA is proportional to 1 over dA. RB is proportional to 1 over dB. If you divide RA over RB, you get dB over dA. So RA over RB is equal, they say A is half of B. So A is half of B. Then RA is 2 times RB. Fourth answer. If you want to find what is VCE, so here you can see this side is a potential divider. That means this place voltage would be 5. So here they say this is 0.6 drop. Then here you will have 4.4. So 4.4 is equal to kilo ohm into I. So I is equal 2.2 milliamp. So the current along this side is 2.2 milliamp. So from here to here, the potential difference 10 is equal 2.2 milliamp into 1 kilo ohm. 1 kilo ohm plus VCE plus 2.2 milliamp into 2 kilo ohm. So this is 2.2 plus VCE plus 4.4, so that is 6.6. Then VCE is 3.4. Second answer. Next, let us look question number 33. In this question, it's slightly different from what you would usually do, because here we have minus 10 degrees Celsius ice and 30 degrees Celsius water. We cannot come to a conclusion whether we are going to get a positive value or a negative value. So let's try this in a new approach. Let's use them separately. 1 minute. So we have 100 grams of water at 30 degrees Celsius, and let's see how much energy will be released if this 100 grams of water at 30 degrees Celsius turns into 0 degrees Celsius. And also let's see how much energy will be gained by ice at minus 10 degrees Celsius to convert to ice at 0 degrees Celsius. So Q1 is equal 0.1 kilogram into 4000 into 30. So that is 1200 joules. Q2 is equal 0.1 2000 into 10, which is 2000 joules. So here when we try to get the idea, we have 30 degrees Celsius water. When we put this minus 10 degrees Celsius ice into this water to become 0 degrees Celsius, it will release 12,000 joules. From that, ice to go from minus 10 to 0, it only used 2000 joules. So we have to account where did that 10,000 joules go. Okay, then we can decide whether this temperature is positive, negative or 0. Obviously here Q1 is greater than Q2, which means when water is going from 30 to 0, it is releasing a lot of heat, but ice to go from minus 10 to 0, it only used 2000. That means for sure we will not get negative answers, because it has sufficient energy to come to 0 degrees Celsius. Now the answer is whether it is 5 or 0. To understand that, we have to see if there is sufficient energy to convert 100 grams of ice. Okay, if this 10,000 is sufficient to convert 100 grams of ice. So we would get let's see, using this 1000, how much ice I can convert. 1000 is equal m into L. 10,000 is equal m into L. L is 3 into 10 to the power 5. So if I simplify these two, I would get 10. M is equal 1 over 30 kilogram. Otherwise 1000 over 30 gram, which is only 33.3 grams. So this 10,000 is only sufficient to convert 33.33 grams of ice to water, which means our final system would have another 66.67 grams of ice remaining, and this water will be at 0 degrees Celsius. So the final temperature of the mixture is 0 degrees Celsius. Third answer. which of the following statement is always true? So remember one thing, when we have resistors connected in series, let's say R1 is greater than R2, then R equivalent is R1 plus R2, right? Which means R equivalent is greater than R1 as well. So you can say resistance will be larger than the largest when we connect it in series. Similarly, when we connect it in parallel, let's say this is R1 and R2, I'll put numbers, say this is 100 and this is 1, then the equivalent will be less than 1. Equivalent will be less than 1. So you can say when connected in parallel, resistance will be smaller than the smallest. Okay, so here let's go through the statements. The current through each resistor in the parallel set of resistors is same. Wrong. Voltage drop across each resistor in the set of series resistors is same. That is also wrong because they will change. The total resistance of the entire network is greater than the resistance of any individual resistor in the set of series resistors. Yes, right? Because as I mentioned, when we connect resistors in series, the equivalent will be anyways larger than the largest. Okay, so the total resistance of the entire network is greater than the resistance of any individual resistor. So this is correct. Anyways, always it is correct. The total resistance of the entire network is less than the largest resistance in the set of parallel resistors. No, because although in this it will be less than the least, but since we are connecting once again it parallel, so in series to these, it will be larger than larger, okay, not smaller. Fifth one is also incorrect, therefore the answer should be third. So they are asking what happens to the de Broglie wavelength when we have electrons like this in electric field and magnetic field. So first E is equal to mc squared, E is equal to hf, but f is c over lambda, then we get lambda is h over mc. So for an electron, h is constant, m is constant, then lambda is inversely proportional to c. So if velocity increase, lambda will reduce and vice versa. So here in electric field, when we have an electron like this, it will move along this direction. That means it is getting attracted, which means its velocity will continuously increase. So lambda will reduce. In a magnetic field, we can use the Fleming's left hand rule. Look from front, then it is like you are having the field coming towards you, electron is moving up. So if we use the Fleming's left hand rule, if B is coming out, B is towards you, current is down because electron is up, then we have a force towards the center. Okay, so here the force is coming out, but look, because of this force, this electron will start to spin around that center. So it will go in a uniform circular motion. Because it's in a uniform circular motion, V doesn't change. If V doesn't change, lambda doesn't change, therefore no change. Then here no change, because F is equal to mv squared over R. M doesn't change, R doesn't change, V doesn't change, because in BQV B didn't change, Q didn't change, velocity also didn't change. Okay, so the answer would be decreases and doesn't change. third. Then we want to find what is its terminal velocity. Okay, so first let's identify the equation for terminal velocity. We know that f u mg, when they are balanced, that is when it moves in a uniform velocity, the terminal velocity. Then f is equal to mg minus u, which is equal 6 pi eta rv. So what I'll try to do is, between these two, between the first droplet and the second droplet, I'll try to remove all the constants. Okay, so instead of mg I can write v rho g minus, instead of upthrust v, now v dash, because volume and velocity is there, is equal 6 pi eta rv. So v dash rho minus sigma minus rho g is equal 6 pi eta rv. Between the first and the second droplet, this is constant. Okay, this term is constant, this term is constant, 6 pi eta is constant. So we get v dash is proportional to rv. What is v dash? That is the volume. So volume is 4 by 3 pi r cube, right? So 4 by 3 pi r cube is proportional rv. So I can cancel this. Velocity is proportional to r square. But what is the relation between volume and radius? Volume is 4 by 3 pi r cube. So it depends only on the radius. Between the first and the second droplet, the volume is 8 times. Okay, that means this has increased by 8 times. If this increases by 8 times, radius only would have doubled. If the radius doubled, velocity would have become 4 times. So already the velocity is 8 for 2 millimeter. For 2 millimeter it is 8. Then our new bubble is only twice the radius, 4 millimeter. Therefore it would be 32 centimeter per second. So fourth answer. Here we want to find what is the refractive index of the liquid. So if this is 45, this is also 45. How to find this angle? Now look, this angle is 90, this angle is 45. In your O levels you would have studied the interior is equal to the exterior, right? I mean sum of interior is equal to the exterior. So if this is 15, this is 75. So now I can write for this interface 1 into sine 45 equal n into sine 30. For this interface, n into sine 75 is equal n dash into sine 90. So first, second, n dash is equal sine 75 into n. But from the first equation I can write n is equal sine 45 over sine 30. So sine 45 is 1 over root 2, sine 30 is half. So we get root 2 sine 75. So the second answer. For these questions, remember that when you have a particle that goes in a motion like this in a liquid, the velocity at here is root 2gh. So here h is y. Now it's a projectile motion. We know the horizontal velocity, so 2gy into t is equal to d. So t is equal d. Next, let's take the vertical motion. In the vertical motion, I can find the time. So s is equal to ut plus half at squared. In the downward direction, initial velocity is 0, right? Then h is equal half gt squared. Then t is equal 2h over g square root. So 2gy square root into 2h over g square root is equal to d. G and g cancel. 4yh square root is d. Then 4yh is equal to d squared. Y is equal d squared over 4h. So that's the third answer. For this question, we have charged particles of mass m1 m2 and charge q1 q2 in radius r1 r2. We want to find m2 v2 over m1 v1. So this is let's start from f is equal to bqv, that is equal to mv squared over r. So v and v cancel, then we get mv is bqr. So mv is proportional to qr because b is anyways constant for both of them. Then m2 over v2, m2 v2 over m1 v1 is equal. For m2 we have charge 2q and radius is 2r. For m1 radius is r and charge is q. So if we simplify we get 4. So fifth answer. Here we want to find the output of the circuit. So here we have a b bar. So here it is a dot b bar. So here we have b and c. So this is b dot c. This is an OR gate. Therefore a dot b bar plus b dot c. First answer. So here question number 41. If you take this particle, we want to find its angular velocity. Okay, so if you consider this particle, the centripetal force is along this direction. Components of this force, so 2t cos 30 minus t cos 30 is equal, how did I get that as 30? This is 2 meters, this is 2 meters, this is also 2 meters. Then equilateral triangle, if this is 30, this is also 30. That is equal m r. What is r? Root 3 given mr omega squared. So here I get t cos 30 m root 3 omega squared. Root 3 cancel. Then T over m into half is equal to omega squared. Now let's look at the vertical direction. In the vertical direction, 2t cos 6t is equal to mg plus t cos 6t. So we get t cos 6t is equal to mg cos 6t is half. So t over m is 2g. So 2g into half is equal omega squared. Did I miss anything? Sorry, here it should be plus, right? Because both of them are getting added when I take the components. So this would be 3t, 2 and 2 cancel, omega is 3g square root. Third answer. Because if you get the components, this is what you get. 2t 30, t is also 30. So the centripetal force is actually the components of them. So if you take the components, this one 2t cos 30, this one is also 2t cos 30, then 3t cos 30. In this direction you get 2t sin 30, t sin 30, and we also have mg. Okay, so this force is acting as the centripetal force over here. These force should balance each other. Okay, that is what I have calculated here. In this question, two identical capacitors are connected by a wire with open switch K. Initially, capacitor X is given charge Q while Y is uncharged. So now this circuit, you can see this place is grounded, this is grounded. So I can read all the circuit like this, bring the same potential together. Okay, now this one has charges. So we know that when we close this switch, these positive charges try to move and come to this side. That means it cannot pass this one, right? Anyways, they are going to get charged. Both of them are going to distribute the charge. Okay, charge of the capacitor decreases to Q by 2. Now say this one has voltage V before closing. After closing, the charge is going, the voltage is going to get distributed, because the potential drop in this entire loop should become V. Then each of them are going to get V by 2 once it is closed. So Q is equal to CV. Both of the capacitors are identical, therefore C is same, but in each of them voltage has become half. The first one voltage has become half, then charge will become half from what it had initially. So initially it had Q, now it will have q by 2. So this is correct. This is wrong because voltage will change. Energy stored in the capacitor will decrease to half of its initial value. So energy stored is half CV squared. V is constant, half is constant, E is proportional to V squared. If V becomes half, E becomes 1/4. So it doesn't decrease by half, it decreases by 4. So only A is correct, first answer. Here we have a block in an inclined plane which is sliding down until half the distance. There is no, the plane is smooth, and after that the plane is rough, so it will lose energy. So here we want to find what is the coefficient of kinetic friction mu. Just know this idea: when we have a smooth plane, okay, say this plane is smooth. If this plane is smooth, here the potential energy we have completely gets converted to kinetic energy. So if you look at the energy is conserved. Okay, we have the same mechanical energy here and here. Instead, potential has changed into kinetic. So let's say this height is h. If this plane was smooth, when it reaches the bottom, it will have a kinetic energy. But here they say when it reaches the bottom, it comes to rest, which means it has lost all of its energy. Okay, it has lost all of its energy it had over here. So here it had mgh, potential energy. When it comes over here, it has potential energy plus kinetic energy. But if you add them, still it will be equal to mgh. Okay, still it will be equal to mgh, because potential would have decreased, kinetic would have increased, but when we add them, it will be mgh. So if it is coming to rest, here, that means all of its energy, this mgh, was lost due to friction from here to here. Okay, so if this height is h, then this would be h by 2, because they say this distance is half, right? They say if this total distance is x, this distance is x by 2. Now I want this distance d. This angle is given as theta. So d cos theta, d sin theta is h by 2. Then d is equal h over 2 sin theta. As I mentioned earlier, work done against friction is equal to this energy, because that's the total energy that has been used up by friction. Then what is the friction? Mu r, but this time r is mg cos theta. What is the distance? H over 2 sin theta is equal to mgh. Mg cancels, h cancels, then mu is equal to sin theta over cos theta, therefore 2 tan theta. First answer. For a satellite moving in around the planet, kinetic energy, gravitational potential, and total energy are given by K, V, and E. What is the relationship between them? We know that potential energy is minus gmm over r. Kinetic energy, if we derive, that is gmm over r. So the total energy gmm over 2r. So the total energy is the sum of them, right? Then we get minus gmm over r plus gmm over 2r. So we get minus gmm over 2r. So they say potential energy is equal to I'll try to write a relation using kinetic energy. So kinetic energy is look, kinetic energy is this, right? That is K. That is equal to, look, potential energy, if I divide by 2 and multiply by 2, I can write this part as K. Then minus potential energy is equal minus 2 times K, that is equal to V. Total energy is equal this part I can write as K minus K, which is equal to E. So I can write E is equal to minus K. That's the first relation. Answer number 1. Here we want to find the resultant force acting on the loop. Remember, when we have current in same direction, they attract. So in this loop, here the current will be in the opposite direction, therefore they will repel. Then the resultant force would be F1 minus F2. Okay, F1 minus F2. But what is the equation for resultant force, magnetic force? BIL. So I'll write B1 current, simple current, B1 I, what is the length? That is B, minus B2 I B. So what is B1? B1 is mu naught I over 2 pi r minus mu naught I over 2 pi, what is the distance to B2? R plus RA. So R plus A. IB. Now mu naught IB over 2 pi 1 over R minus 1 over R plus A. If you simplify, you get mu naught IB over 2 pi R into R plus A into A. So fourth answer. Here we have a PV graph and we want to find the temperature at point C. So in a PV graph, so PV is equal to nRT, right? In a PV diagram, same gas is going in a cycle. N is constant, R is constant. Then PV is proportional to the temperature. So if you want to find the temperature, you only need to get the product, and that will be proportional to the temperature. So at A, the product is 4 into 6, that is 48. Proportional absolute temperature. So what's the absolute temperature? 327 plus 273. So that's 600. And what is the product at C? That is 9 into 4, 36. Proportional TC. So 48 over 36 is equal 600 TC. So TC is 600 into 36 over 48. So if I divide this by 4, I get 9. If I divide this by 4, I get 12. 600 divided by 12, it is 50. 50 into 9, that is 450 Kelvin. But I need degree Celsius temperature. So 450 minus 273. 450 minus 273, that is 177 degrees Celsius. So we get the first answer. We want to draw the temperature versus length, and they have mentioned half part is lagged and remaining is unlagged. So when it is lagged, we know that here the area nothing changes, right? Therefore we will get a straight line graph that is decreasing. So answer could be only 3 or 4. And when it is unlagged, temperature will lose quickly, right? Heat will go away quickly. Therefore temperature should decrease quickly. That means here it is decreasing quickly. Then the fourth answer. So question number 48. Here they mention when liquid is when a person is looking straight, he only can see up to height h. But when we fill liquid up to height 2h, if we fill up to height 2h, he can see the bottom. Then what is the refractive index of the liquid? So here we need to find what is this angle, right? To find that angle, this angle when we fill liquid, this angle over here and this angle over here is same. So to find this angle, I can find this angle. So here this length is how much? 2h. This is 3h minus h, then this is 2h. So this angle should be 45. Then this angle is 45. Similarly, I need to find what is this angle over here, the refracted angle. Okay, now the liquid is filled up to this level. I need to find what is this angle with the normal. Okay, for that this height is how much? 2h, because we are only filling liquid to height 2h, and this is how much? H. Then I can say this angle is theta. So tangential side would be square and square root, right? Sum of the sides, sum of square of the sides, square root. So 4 squared plus 1 squared, 5 squared. So this is root 5h. Okay, so I can write 1 into sine 45 is equal n into sine theta. But what is sine theta? So opposite over hypotenuse. Opposite is h, hypotenuse is root 5h. So h and h cancel. Sine 45 is root 1 over root 2. Then n is 5 over 2 root. So that is the second answer. We have an operational amplifier. If you look at this operational amplifier, we are giving an triangular wave for V in with a peak to peak voltage of 5 volt ranging from minus 2.5 to 2. And it is given to the it is given to the inverting input. That means if the value it's given to the non-inverting input, that means they are saying that we are giving it to the negative terminal. Here if you look at this operational amplifier, this is in open loop. So in open loop, there's no feedback resistor, right? There's no feedback resistor. Then this is open loop. In open loop, it is just a voltage comparator. That means if this voltage is less than 1.5, that means V plus is greater than V minus, then output voltage will saturate to positive side. That means the output voltage becomes plus 5. If V in is greater than V plus, that means V minus is greater than V plus, now the output voltage will saturate to negative side. Then output would be minus 5. So here a small change is sufficient. Okay, let's keep that in mind and check the answers. Our answer, this is going from minus 2.5 to plus 2.5. This is going from minus 2.5 to plus 2.5. Then I can understand that it has values less than 1.5 and more than 1.5. So output will saturate to both sides, plus and minus 5. Let's select the answers where it saturates to plus and minus 5. This is not possible because it is not saturating. This is not possible because it is not going to the negative side. It stops at 0. This is also not possible because when it is saturating, it should go up to minus 5. So these are the possible answers. From them, when V in is on the positive side, let's say V in is 2.5, which is greater than 1.5. 2.5 is greater than 1.5. So on this side you have 2.5 and here you have 1.5. Which one is greater, V plus or V minus? V minus is greater. During that, this should be a negative voltage. So when you are getting a positive, V minus is greater than 1.5, you should get negative value. So here you are getting negative value, but here you are getting positive value. Therefore the answer is fourth. What is the largest value the wedge can balance without slipping? So let's consider only one of the wedge. If you take this mass, you have reaction forces R and R. This angle over here is 45 and here the weight is mg. So we can understand that 2r cos 45 balances mg. Then r is root 2 mg. If you simplify, no, root 2 over 2 mg. Otherwise mg over root 2. Now let's take the wedge. If we take the wedge, in the wedge we have reaction from the sphere, okay, and due to this wedge is trying to move away in this direction, r cos 45, and it is balanced by the friction Fr. In addition to weight mg, we also have a component of this weight, reaction, r sin 45. So the reaction from the flow on the wedge r dash is equal mg plus r sin 45. Fr is equal mu r dash is mg plus r sine 45. So that is also equal to, now if this should be balanced without moving, this and this forces should be balanced. This is equal to r cos 45. But look here, in this equation I can take r cos 45 straight away. R cos 45 is equal mg over 2. R cos 45 and r sin 45 are equal, therefore I can write mu mg plus instead of r sin 45, mg by 2 is equal mg by 2. So I can cancel all the g. Mu is equal 2m plus m over 2 is equal m over 2. 2 and 2 cancel. Then mu is m over, we need to subject capital M. Then we have, I'll continue here. 2m mu plus m mu is equal to m. Then 2m mu is equal m 1 minus mu, then m is equal 2m mu over 1 minus mu. So that is the fifth answer.